Every night, when you look up at the stars, you are witnessing a story billions of years in the making. Each point of light is a sun, each galaxy a vast city of suns, and each cluster a gathering of countless worlds. Human beings have always been captivated by scale, the tiny, the immense, the spaces we cannot imagine. From the ant crawling in the grass to the farthest quasar at the edge of the observable universe, we measure, compare, and wonder. It begins with perspective. Our Earth, a pale blue dot in the vast darkness, is less than 1 light-second across. The Moon is about 250,000 miles away, a distance we can comprehend, yet already almost impossible to imagine fully. The Sun, a giant ball of nuclear fire, stretches 109 times wider than Earth. Even our largest cities, our largest oceans, shrink to near nothing compared to the distances between stars. And then comes the first leap, the stars themselves. Some are small, like red dwarfs barely a fifth the mass of the Sun. Others, the supergiants, are colossal, hundreds, sometimes 1,000 times the size of our own star. A star like Scuti, for example, could swallow the orbits of planets we know, reaching distances that dwarf our entire solar system. When we think of big, we must realize the mind struggles to grasp the scale of these celestial giants, yet stars are not alone. They gather into galaxies, vast islands of stars, gas, dust, and dark matter, bound by the invisible grip of gravity. The Milky Way, our home galaxy, contains hundreds of billions of stars, stretching roughly 100,000 light-years across. We inhabit just one tiny corner, spinning around an ordinary star, in one galaxy among billions, and galaxies in turn group together. Clusters of galaxies form, gravitationally bound and dancing in cosmic ballets. These clusters form superclusters, creating webs of unimaginable proportions. The Laniakea supercluster, which contains the Milky Way, spans over 500 million light-years, a scale that challenges even the imagination. Humans have always sought to measure the unmeasurable. We look for the largest mountains, the longest rivers, the tallest trees. Yet when we step into the universe, these measures pale into insignificance. Here, scale is not just large, it is incomprehensible. The distances are measured not in miles, kilometers, or even light-years, but in billions of light-years. And as we wonder about scale, another question arises. What is the largest thing in the universe? Is it a star, a galaxy, a massive cluster, or perhaps something we have not yet discovered? This question has haunted astronomers, philosophers, and dreamers alike. Because to answer it is to confront the infinite, to measure the immeasurable, to comprehend the vastness of existence itself. Yet, before we attempt to answer, it is important to understand why scale matters. Scale is how the universe communicates with us. The smallest particles reveal the rules of matter. The largest structures reveal the rules of existence. And in between, we find ourselves being small enough to marvel, yet conscious enough to measure and explore. In every age, humans have gazed upward, imagining worlds beyond our own. From the first naked-eye astronomers counting stars, to the great telescopes of modern science mapping galaxies across billions of light-years, our fascination with the cosmos has been a constant. We seek patterns, connections, and meaning in the vast tapestry of space. And in this quest, we begin to recognize a profound truth. Scale is not just a measure of size. It is a measure of perspective, of understanding, and of wonder. Tonight, as you drift into sleep, let your mind travel along this cosmic ladder. From your fingertips to the moon, from the sun to the Milky Way, from clusters of galaxies to the furthest walls of the cosmos. Imagine the grand, silent structures stretching beyond comprehension, and feel your place within them. You are small, yes, but you are also conscious, able to witness, to question, to dream. And that is the unique gift of humanity, the ability to see, understand, and marvel at the largest mysteries of all. Scale is the first step toward awe. It reminds us that the universe is not simply a backdrop for our lives. It is an intricate, living, expanding system in which we are both insignificant and profoundly connected. Every atom in your body has traversed the cosmos, forged in the heart of a star billions of years ago. Every thought you have is the echo of universal laws, stretching from the tiniest particle to the largest galaxy. So let us begin our journey into the largest thing in the universe, not as a cold exercise in measurement, but as a meditation on awe, perspective, and the endless grandeur of existence. Because the bigger the universe, the greater the mystery. And as we explore it, we begin to explore ourselves. Stars, the first giants. Look up at the night sky, and you see points of light scattered across the darkness. At first, they may seem small, delicate, distant, mere pinpricks on a canvas of black. But each of those lights is a star, a colossal sphere of burning gas, radiating energy across incomprehensible distances. And while the sun, our familiar companion, is a giant in its own right, it is but a modest star in the grand spectrum of cosmic giants. Stars vary enormously in size. Some, the red dwarfs, are small and faint, barely one-fifth the mass of the sun. They burn slowly and steadily, often for trillions of years, quietly enduring in the cosmic night. Other stars, like the supergiants, dwarf entire solar systems. Consider Uy, a red supergiant over 1,000 times the radius of our sun. If it were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. The scale is so vast that it challenges not just our imagination, but the very limits of comprehension. How do scientists measure such stars? Through light, through gravity, through careful observation of luminosity and distance. By studying the brightness and color of a star, astronomers can determine its temperature and size. By observing its effects on surrounding objects, companion stars, orbiting planets, or gas clouds, they can calculate mass. Each method is a delicate balance of mathematics and intuition, of observation and inference, revealing secrets that lie millions of light years away. Stars are not eternal. They are born from clouds of gas and dust, collapsing under gravity's pull. The densest regions ignite nuclear fusion, sparking a star into life. For billions of years, it burns, fusing hydrogen into helium, radiating warmth and light. Some stars, like our sun, have a steady, calm life, lasting 10 billion years. Others, the massive stars, burn brighter, hotter, faster. Their lives are brilliant but brief, lasting only millions of years. And then, at the end of their lives, these giants explode. Supernovae scatter elements into space, seeding future stars, planets, and even life itself. Iron, oxygen, carbon, calcium, all forged in stellar cores, all born of the life and death of stars. Every atom in your body, every grain of sand on Earth, every drop of water in the ocean has passed through a star. In that sense, stars are not just distant lights. They are our ancestors, our makers, the cosmic architects of existence. Some stars exist in isolation. Others form clusters, spinning together in elegant cosmic ballets. Binary stars, trios, and even massive groups reveal complex gravitational dances, each motion a precise echo of universal laws. And as we measure, observe, and study these giants, we are reminded of both our smallness and our deep connection to the cosmos. But there are limits to what a star can be. The most massive stars approach the brink of stability. If a star grows too large, gravity can no longer contain the outward pressure of fusion. These stars live fast, die young, and leave behind neutron stars or black holes, dense remnants that challenge physics itself. They are both the beginning and the end, the creators and destroyers in a cycle that repeats across the universe. Tonight, as you imagine these stellar giants, let yourself drift across their vast surfaces. Picture the sunburnt winds of a massive star, the molten energy churning in its core, the fusion fires that illuminate galaxies far away. Feel the pulse of creation in every explosion, every flare, every shining point in the night. Stars are the first giants of the universe, majestic, powerful, awe-inspiring. They teach us the scale of existence and the fleeting nature of life. They remind us that even in the vast darkness, light persists, warmth endures, and matter is endlessly transformed. And as you drift further into this cosmic meditation, remember, the stars are not just out there. They are within us. Their elements, their energy, their very essence flow through every living being. In understanding stars, we understand ourselves. In marveling at their enormity, we grasp a fraction of the universe's infinite beauty. Galaxies, islands of stars. If stars are the first giants of the universe, then galaxies are the grand cities that house them. Each galaxy is a magnificent collection of billions, sometimes trillions of stars, bound together by gravity, gas, dust, and dark matter. They are the islands of the cosmos, vast archipelagos in the ocean of space, each unique in form, scale, and character. Our home, the Milky Way, is a spiral galaxy, with a central bulge of dense stars and majestic arms curling outward. It stretches roughly 100,000 light-years across, containing hundreds of billions of stars. Within its arms, stars are born, live, and die, creating patterns of light and motion that have persisted for billions of years. And yet, when compared to some of the universe's giants, the Milky Way is modest, a mid-sized galaxy in a cosmos of extremes. Galaxies come in many forms. Spirals like our own spin gracefully, with arms full of gas, dust, and newborn stars. Elliptical galaxies are more rounded, smoother, often containing older stars and less interstellar gas. Irregular galaxies defy order, chaotic in shape, yet no less magnificent. Each type tells a story of formation, collision, evolution, and the ceaseless rhythm of cosmic life. Some galaxies are small, only a few billion stars, while others dwarf them all. IC 1101, located over 1 billion light-years away, stretches 6 million light-years across, 60 times the size of the Milky Way. It contains trillions of stars, each shining its own light across unimaginable distances. Imagine that, a single galaxy, larger than some entire clusters of galaxies, quietly drifting in the cosmic night. The scale is so immense that human minds struggle to grasp it. Galaxies do not exist in isolation. They gather into clusters, gravitationally bound groups of galaxies that dance together over millions of light-years. These clusters form superclusters, massive structures containing tens of thousands of galaxies. Our own Milky Way resides in the Laniakea supercluster, which stretches over 500 million light-years, a structure so vast it challenges the imagination itself. But galaxies are not static. They collide, merge, and evolve over billions of years. When galaxies interact, stars rarely collide directly, but gravity reshapes their paths, triggering bursts of star formation, bending the shapes of entire galaxies, and sometimes creating enormous cosmic fireworks. These galactic interactions are a reminder that the universe is alive with motion, a slow, graceful dance choreographed by gravity across incomprehensible distances. Within galaxies, stars are born in clouds of gas and dust, forming stellar nurseries glowing with ultraviolet light. Over time, stars age, die, and release elements that seed future generations of stars and planets. Planets form around these stars, and within those planets, life may arise, just as it did on our own small world. Every galaxy, therefore, is not just a collection of stars. It is a cradle of creation, a cosmic laboratory for the unfolding story of existence. And then there is dark matter, the invisible scaffolding holding galaxies together. Without it, galaxies would fly apart, unable to resist the pull of centrifugal forces. Dark matter is unseen, yet essential, a reminder that much of the universe is hidden from our senses, waiting to be discovered. Tonight, let your mind drift across the spiral arms of the Milky Way. See the brilliant clusters of young stars, the quiet glow of ancient stars in the bulge, the dark lanes of cosmic dust weaving patterns across the galaxy. And then drift further, beyond our familiar neighborhood, to IC 1101, to the clusters and superclusters, to the cosmic web that stretches for billions of light years. Feel the vastness, the beauty, the slow, elegant rhythm of galaxies as they rotate, collide, and evolve. Galaxies are more than astronomical objects. They are symbols of scale, of complexity, of the astonishing beauty of the universe. They remind us that even as humans, tiny and fleeting, we are part of something immense and eternal. Every atom in our bodies was forged in the stars. Every heartbeat, every thought, every dream is connected to these cosmic cities of light. So as you close your eyes and drift into this meditation, imagine yourself floating among the galaxies, carried by the quiet forces of gravity, starlight illuminating your path. You are both witness and participant in this cosmic dance, a part of the infinite story that stretches across time and space. Galaxy clusters and superclusters. When we gaze at a single galaxy, it is easy to feel that we are looking at the pinnacle of cosmic scale. A galaxy contains billions of stars, swirling in delicate patterns, forming clusters, arms, and dense cores. Yet even the largest galaxies are not solitary islands. They are social beings in a vast cosmic ocean, gathering into communities bound by the invisible hand of gravity. These communities are called galaxy clusters. A galaxy cluster is a collection of hundreds, sometimes thousands, of galaxies held together by gravity. They can span millions of light years, with galaxies moving through space at incredible speeds, hundreds or even thousands of kilometers per second. Within a cluster, galaxies interact, collide, and sometimes merge, creating new forms and reshaping the cosmic landscape. Yet despite the chaos, the cluster holds together, a delicate balance between gravitational pull and orbital motion, a cosmic dance that persists for billions of years. One of the most famous clusters is the Virgo cluster, located about 55 million light-years from Earth. It contains over 1,300 galaxies, each with its own collection of stars, planets, and mysteries. Our own Milky Way is a member of this larger community, the local group, which itself is a small cluster of about 50 galaxies. Clusters can range from modest groups like the local group to immense structures like the Coma cluster, containing thousands of galaxies stretching millions of light years. Clusters are more than gatherings of stars. They are laboratories of cosmic evolution. Within clusters, galaxies collide, triggering bursts of star formation. Supermassive black holes at galactic centers awaken, consuming gas and dust, sending out powerful jets that shape their surroundings. Hot gas fills the spaces between galaxies, glowing in X-rays, invisible to the naked eye but detectable by powerful instruments. In a galaxy cluster, the unseen is as important as the seen. Dark matter forms the scaffolding that keeps the cluster intact, holding these immense structures together against the relentless pull of gravity. Clusters themselves form even larger structures called superclusters. Superclusters are vast networks of clusters, connected in a cosmic web spanning hundreds of millions of light years. They reveal a higher level of order, a grand architecture that stretches across the observable universe. Our own Milky Way resides in the Laniakea supercluster, a cosmic city encompassing over 100,000 galaxies. Laniakea spans more than 500 million light-years, a scale so immense that our minds struggle to comprehend it. Within a supercluster, galaxies are not randomly distributed. They trace the filamentary structure of the universe, forming chains, walls, and sheets of matter separated by immense voids. These cosmic filaments, invisible to the naked eye, are like the veins of the universe, carrying matter, energy, and history across unimaginable distances. The Hercules, Corona Borealis Great Wall, the largest known structure in the observable universe, stretches over 10 billion light-years. It is a cosmic monument to scale and complexity, a reminder that the universe is far vaster than we can perceive. As we explore clusters and superclusters, we begin to see the universe as a living system. Gravity is the conductor, dark matter the hidden scaffolding, and galaxies the instruments, playing their roles in a symphony of cosmic motion. Collisions create harmonies of star formation. Black holes punctuate with deep, resonant notes. Superclusters sway slowly, almost imperceptibly, across billions of years, like movements of a grand cosmic symphony. Clusters and superclusters are also markers of time. They reveal the history of the universe, the imprint of cosmic evolution. Some clusters are young, still forming, with galaxies rushing together for the first time. Others are ancient, long stabilized, with galaxies quietly orbiting in well-rehearsed patterns. By studying these structures, astronomers reconstruct the story of the cosmos, how matter gathered, how gravity shaped it, and how the universe grew from a nearly uniform cloud of gas into the intricate tapestry we see today. Beyond scale and structure, clusters inspire perspective. They remind us that we are part of something much larger than ourselves. Every galaxy in a cluster contains billions of stars. Every star may host planets, some perhaps capable of harboring life. And all of these galaxies are bound together, forming communities on scales that defy imagination. Tonight, let your mind float among the galaxy clusters. Imagine the Milky Way drifting quietly, part of the local group, itself within Laniakea. Picture galaxies colliding, forming new stars in brilliant bursts of light. Visualize the vast, glowing clouds of hot gas, the unseen dark matter weaving everything together. Feel the immense scale, the interconnectedness, the cosmic rhythm of gravity in motion. Clusters and superclusters are the bridges between individual galaxies and the cosmic web. They are the milestones of scale, the way the universe organizes itself. And they reveal a universe that is not chaotic, but structured, orderly, and astonishingly beautiful. As you drift further into this meditation, realize that every particle in your body has traveled through such cosmic systems. The atoms forged in stars, carried through galaxies, and scattered across clusters eventually coalesce to form Earth, life, and you. You are connected in every sense to the vast web of galaxies stretching across the universe. And so, in contemplating clusters and superclusters, we are contemplating both scale and connection. We are witnessing the universe at its grandest, yet we are intimately linked to every star, every galaxy, every motion within this cosmic dance. Clusters remind us that the universe is vast, ancient, and complex, and that our curiosity, our awareness, and our wonder are part of that same vastness. Cosmic web, the universe's skeleton. As we step back from individual galaxies, clusters, and superclusters, we begin to see the universe in a new light, not as scattered points of matter, but as an intricate, interconnected structure. This is the cosmic web, the skeleton of the universe, stretching across unimaginable distances, weaving galaxies, clusters, and superclusters into a single, cohesive tapestry. The cosmic web is composed of filaments, walls, and nodes, threads of dark matter and ordinary matter, forming a vast lattice across space. Galaxies are not randomly scattered. They trace these filaments, gathering along them like dew along threads of a spider's web. Between these filaments lie immense voids, regions of space nearly empty of galaxies, vast cosmic deserts spanning hundreds of millions of light years. It is in the contrast between the dense filaments and the empty voids that the universe reveals its grand architecture. Imagine floating above the universe, gazing down on this immense web. You would see threads of galaxies stretching endlessly in all directions, interwoven with clusters and superclusters. Some filaments connect hundreds of thousands of galaxies, forming walls so immense they defy comprehension. The Hercules, Corona Borealis Great Wall, for example, spans more than 10 billion light-years, a structure so vast that it challenges even the limits of scientific understanding. Dark matter forms the invisible scaffolding of the cosmic web. Though unseen, it exerts gravity, guiding the formation of galaxies and clusters along its filaments. Without it, galaxies would drift apart. Without it, the web would unravel. Dark matter is the silent architect, shaping the universe in ways we can detect only indirectly, through the motion of stars, the bending of light, and the distribution of galaxies. The cosmic web is also a record of cosmic history. Its filaments formed from tiny fluctuations in the density of matter shortly after the Big Bang. Over billions of years, these fluctuations grew under the pull of gravity, drawing matter into filaments, clusters, and superclusters. The web is, in essence, the universe's memory, a vast map of how matter evolved from a nearly uniform sea to the intricate tapestry we see today. Within the cosmic web, galaxies are born, live, and die. They follow the filaments, merging at nodes where clusters form. Star formation ignites, black holes awaken, and elements are scattered across space, enriching the intergalactic medium. The cosmic web is not static. It is alive with motion, a slow, elegant dance spanning billions of years, yet imperceptible in human lifetimes. The voids between filaments are equally fascinating. They are enormous empty regions, sometimes hundreds of millions of light-years across. Within these voids, galaxies are sparse and isolated, quietly drifting through near-nothingness. The contrast between the dense filaments and these empty expanses highlights the remarkable organization of the universe. As you drift through this mental journey, picture yourself floating along a cosmic filament. You pass galaxy after galaxy, each spinning, shining, and evolving. Clusters form at nodes, massive and ancient, glowing with the light of trillions of stars. You cross a void, the silence is profound, a vast emptiness stretching beyond imagination. And then another filament appears, a bridge of galaxies connecting clusters like a delicate web of cosmic light. The cosmic web reminds us of the unity of the universe. Every star, every galaxy, every cluster is connected, part of an interwoven structure that spans billions of light years. It is a system of balance. Gravity pulls, dark matter supports, matter organizes, and through it all, the universe grows, evolves, and expands. Tonight, as you let your mind float among these filaments, consider your own place in this cosmic structure. You are a small observer on a tiny planet, yet your consciousness allows you to perceive the web, to understand its scale, to marvel at its complexity. Every atom in your body, every element that makes up your existence, was once shaped by stars within galaxies, guided along these cosmic highways and scattered across clusters. You are not separate from the universe. You are part of its vast, interconnected web. The cosmic web is the universe's skeleton, its structure, its architecture. It teaches us about scale, connection, and time. It invites awe, reflection, and contemplation, reminding us that the universe is far more immense and intricate than we can fully imagine. And yet, within this vastness, our curiosity, awareness, and wonder are echoes of the same forces that shape the galaxies themselves. So as you close your eyes, drift with the filaments, float past clusters and nodes, and soar through voids of unimaginable emptiness. Feel the slow rhythm of cosmic motion, the gentle tug of gravity, and the silent hum of dark matter. Know that you are part of this grand web, a witness to the largest structures ever known, and a participant in the ongoing story of the cosmos. Measuring the universe to explore the universe, to comprehend its vastness, we must first measure it. Yet measuring the cosmos is unlike measuring anything on Earth. Distances are so vast that common units like miles or kilometers quickly become meaningless. Instead, astronomers use the language of light years, parsecs, and redshift, tools that allow the mind to stretch across the incomprehensible scales of space. A light year is the distance light travels in 1 year, about 6 trillion miles. It is both a measure of distance and a measure of time. When we observe a star 10 light-years away, we are seeing it as it was 10 years ago. When we observe a galaxy billions of light-years away, we are peering back in time billions of years, watching the universe as it existed long before life appeared on Earth. To measure and map the universe, we rely on the most powerful tools ever created, telescopes. These instruments collect light across the electromagnetic spectrum: visible light, radio waves, infrared, ultraviolet, X-rays, and gamma rays. Each wavelength tells a different story. Radio telescopes can map the cold hydrogen gas between galaxies, revealing the scaffolding of the cosmic web. Infrared telescopes can peer through clouds of dust, unveiling stars in the process of formation. X-ray telescopes can detect the hot gas within galaxy clusters, glowing at millions of degrees, invisible to ordinary vision. But light alone is not enough. To determine distances to galaxies, astronomers use a phenomenon called redshift. As the universe expands, light traveling through space is stretched, shifting toward longer wavelengths. The faster a galaxy recedes, the more its light is redshifted. By measuring this redshift, scientists can calculate how far away the galaxy is and how fast it is moving. This simple principle allows us to map the positions of galaxies across billions of light years, to construct three-dimensional maps of the universe. Measuring the size of galaxies and clusters is equally fascinating. The apparent size of an object depends on its distance and the resolution of the telescope. Nearby galaxies can be studied in exquisite detail, revealing individual stars, star clusters, and nebulae. Distant galaxies appear as faint smudges, their light stretched and dimmed by cosmic expansion. Yet by analyzing the distribution of light, astronomers can infer the structure, mass, and scale of these faraway systems. Even the largest structures in the universe, superclusters, filaments, and walls, can be detected through clever techniques. One approach is large-scale galaxy surveys, such as the Sloan Digital Sky Survey. By cataloging millions of galaxies, their positions, and redshifts, scientists can reconstruct the cosmic web, revealing filaments, voids, and the largest walls ever discovered. Through this method, structures like the Hercules, Corona Borealis Great Wall emerged from the data, massive filaments stretching billions of light years, invisible to the eye but undeniable through careful measurement. But measuring the universe is not without challenges. Distances are immense. Light takes billions of years to reach us, meaning we are always observing the past, never the present. Galaxies may be obscured by dust or lie behind brighter foreground objects. Cosmic expansion and gravitational lensing bend light, distorting the appearance of distant objects. Even dark matter, which forms the bulk of cosmic mass, is invisible, detectable only through its gravitational influence. Astronomers combine multiple techniques to overcome these challenges. Standard candles, such as Cepheid variable stars and Type Ia supernovae, provide a way to gauge distances by their intrinsic brightness. Gravitational lensing reveals the distribution of mass, both visible and dark, by how it bends the light of background galaxies. Large-scale surveys, sophisticated computer simulations, and precise observations across multiple wavelengths all come together to paint a picture of the universe. The scale of the universe makes measurement a matter of patience and precision. Some surveys take years, even decades, to complete. Data from space-based observatories like the Hubble Space Telescope, the James Webb Space Telescope, and X-ray observatories complement ground-based instruments, giving us a multi-layered view of the cosmos. By combining observations across time and wavelength, scientists build maps that reveal the size, shape, and structure of the universe at its largest scales. Yet, even with our most powerful tools, the universe continues to challenge us. Some structures appear larger than our models predict. Galaxies move in unexpected ways, hinting at unseen matter. The expansion of the universe accelerates, defying our understanding of gravity alone. Every measurement, every observation brings answers and new questions. The universe is a puzzle whose pieces are scattered across billions of light years, and our task is to assemble them, piece by piece, observation by observation. As you let your mind drift through this meditation, imagine yourself as a cosmic observer. You peer through a telescope, scanning the heavens. You measure the light of distant galaxies, chart their positions, and trace the invisible threads of the cosmic web. You feel the immensity of space, the depth of time, and the delicate precision of measurement that allows you to comprehend even a fraction of it. Measuring the universe is more than a scientific endeavor. It is an exploration of scale, connection, and meaning. It is a dialogue between human curiosity and the cosmos itself. Every data point, every light year calculated, every redshift measured, is a bridge linking us to the vast, incomprehensible universe. Tonight, as you close your eyes, let your imagination soar. Picture the telescope scanning distant skies, capturing photons that traveled billions of years. Visualize astronomers decoding the signals, mapping galaxies, tracing the cosmic web, unveiling structures that stretch beyond comprehension. Feel the wonder, the humility, the awe of being able to measure, understand, and exist within this grand cosmos. Measuring the universe reminds us that the cosmos is not only vast, but knowable, at least in part. And through patience, observation, and imagination, we begin to touch the edges of infinity, to comprehend the scale of existence, and to marvel at the intricate beauty of the universe. Dark matter and dark energy, the invisible forces of the cosmos. As we measure the universe, we quickly realize that much of what exists is invisible. The stars, galaxies, and clusters that we can see, bright beacons across the cosmos, are only a small fraction of the total mass of the universe. The rest is hidden, unseen, yet its presence shapes everything we observe. This is the realm of dark matter and dark energy, the invisible forces that govern the cosmos. Dark matter was first inferred by observing galaxies. Stars at the edges of galaxies orbit faster than expected, as if unseen mass were pulling them inward. Galaxies within clusters move in ways that defy the pull of visible matter alone. There must be something else, something invisible, creating gravity, holding galaxies together, shaping the universe's large-scale structure. We call this unseen substance dark matter. Dark matter does not emit, absorb, or reflect light. It cannot be seen with any telescope. Yet its gravitational influence is undeniable. Without dark matter, galaxies would fly apart. Without it, the cosmic web would collapse. It is the hidden scaffolding, the invisible framework upon which the universe is built. But even more mysterious than dark matter is dark energy. In the late 1990s, astronomers discovered that the expansion of the universe is accelerating. Galaxies are not only moving apart, They are moving apart faster and faster. Some unknown energy, pervasive and repulsive, drives this acceleration. We call it dark energy. It constitutes roughly 70% of the universe, yet we know almost nothing about it. It stretches the fabric of space itself, influencing the fate of the cosmos. Dark matter and dark energy shape the universe in profound ways. Dark matter guides the formation of galaxies along filaments of the cosmic web. Dark energy drives the expansion of space, pushing clusters, superclusters, and voids further apart over billions of years. Together, they dominate the universe, yet remain largely invisible to our senses. They remind us that what we see, stars, planets, gas clouds, is only a fraction of what truly exists. How do scientists study the invisible? Through indirect observation, careful measurement, and clever inference. Gravitational lensing reveals dark matter by the way it bends light from distant galaxies. Galaxy rotation curves expose unseen mass within galaxies. Large-scale surveys map the distribution of matter, revealing the cosmic web shaped by both dark matter and dark energy. Even the cosmic microwave background, the afterglow of the Big Bang, carries subtle imprints of these invisible forces, clues encoded in the earliest light of the universe. Despite decades of study, dark matter and dark energy remain enigmatic. We know they exist, yet their nature eludes us. Are they exotic particles we have yet to discover? Are they properties of space itself? Do they point to new physics beyond our current understanding? Each answer only deepens the mystery, inviting curiosity, imagination, and wonder. As you drift through this cosmic meditation, picture yourself floating in a galaxy. Stars spin around you, their light bright and familiar. Yet all around, unseen, dark matter cradles the galaxy, guiding its motion. Beyond, space stretches, driven apart by dark energy, accelerating the expansion of the universe. You are immersed in the interplay of visible and invisible, of forces both known and unknown, of structures and motions that span billions of light years. Dark matter and dark energy teach us humility. They remind us that human perception is limited. They reveal a universe far more complex than our senses alone can detect. Yet through careful observation, through measurement, through mathematics and imagination, we begin to glimpse the unseen architecture of reality. Tonight, let your mind drift along these invisible threads. Feel the gentle pull of dark matter, holding galaxies in silent embrace. Sense the quiet push of dark energy, stretching space and time across the cosmos. Imagine the cosmic web, vast filaments glowing faintly with galaxies, suspended within an unseen framework of immense, pervasive forces. You are not just observing the universe. You are participating in it, connected to these invisible structures through the very atoms and energy that compose you. Dark matter and dark energy are the universe's silent symphony. They shape the dance of galaxies, the expansion of space, and the ultimate fate of all cosmic structures. They challenge our understanding, expand our imagination, and invite a deep, meditative awe at the scale, complexity, and mystery of existence. As you close your eyes, imagine drifting through this invisible cosmos. Feel the unseen gravity guiding galaxies, the expanding space stretching endlessly around you. Know that even as a single observer, on a tiny planet in a modest galaxy, you are intimately connected to these vast, invisible forces. The universe is larger, stranger, and more beautiful than anything we can fully grasp, and yet, through science, observation, and wonder, we touch its edges and feel its rhythm within us. Dark matter and dark energy, the invisible forces of the cosmos. As we measure the universe, we quickly realize that much of what exists is invisible. The stars, galaxies, and clusters that we can see, bright beacons across the cosmos, are only a small fraction of the total mass of the universe. The rest is hidden unseen, yet its presence shapes everything we observe. This is the realm of dark matter and dark energy, the invisible forces that govern the cosmos. Dark matter was first inferred by observing galaxies. Stars at the edges of galaxies orbit faster than expected, as if unseen mass were pulling them inward. Galaxies within clusters move in ways that defy the pull of visible matter alone. There must be something else, something invisible, creating gravity, holding galaxies together, shaping the universe's large-scale structure. We call this unseen substance dark matter. Dark matter does not emit, absorb, or reflect light. It cannot be seen with any telescope. Yet its gravitational influence is undeniable. Without dark matter, galaxies would fly apart. Without it, the cosmic web would collapse. It is the hidden scaffolding, the invisible framework upon which the universe is built. But even more mysterious than dark matter is dark energy. In the late 1990s, astronomers discovered that the expansion of the universe is accelerating. Galaxies are not only moving apart, they are moving apart faster and faster. Some unknown energy, pervasive and repulsive, drives this acceleration. We call it dark energy. It constitutes roughly 70% of the universe, yet we know almost nothing about it. It stretches the fabric of space itself, influencing the fate of the cosmos. Dark matter and dark energy shape the universe in profound ways. Dark matter guides the formation of galaxies along filaments of the cosmic web. Dark energy drives the expansion of space, pushing clusters, superclusters, and voids further apart over billions of years. Together, they dominate the universe, yet remain largely invisible to our senses. They remind us that what we see, stars, planets, gas clouds, is only a fraction of what truly exists. How do scientists study the invisible? Through indirect observation, careful measurement, and clever inference. Gravitational lensing reveals dark matter by the way it bends light from distant galaxies. Galaxy rotation curves expose unseen mass within galaxies. Large-scale surveys map the distribution of matter, revealing the cosmic web shaped by both dark matter and dark energy. Even the cosmic microwave background, the afterglow of the Big Bang, carries subtle imprints of these invisible forces, clues encoded in the earliest light of the universe. Despite decades of study, dark matter and dark energy remain enigmatic. We know they exist, yet their nature eludes us. Are they exotic particles we have yet to discover? Are they properties of space itself? Do they point to new physics beyond our current understanding? Each answer only deepens the mystery, inviting curiosity, imagination, and wonder. As you drift through this cosmic meditation, picture yourself floating in a galaxy. Stars spin around you, their light bright and familiar. Yet all around, unseen, dark matter cradles the galaxy, guiding its motion. Beyond, space stretches, driven apart by dark energy, accelerating the expansion of the universe. You are immersed in the interplay of visible and invisible, of forces both known and unknown, of structures and motions that span billions of light years. Dark matter and dark energy teach us humility. They remind us that human perception is limited. They reveal a universe far more complex than our senses alone can detect. Yet through careful observation, through measurement, through mathematics and imagination, we begin to glimpse the unseen architecture of reality. Tonight, let your mind drift along these invisible threads. Feel the gentle pull of dark matter, holding galaxies in silent embrace. Sense the quiet push of dark energy, stretching space and time across the cosmos. Imagine the cosmic web, vast filaments glowing faintly with galaxies, suspended within an unseen framework of immense, pervasive forces. You are not just observing the universe. You are participating in it, connected to these invisible structures through the very atoms and energy that compose you. Dark matter and dark energy are the universe's silent symphony. They shape the dance of galaxies, the expansion of space, and the ultimate fate of all cosmic structures. They challenge our understanding, expand our imagination, and invite a deep, meditative awe at the scale, complexity, and mystery of existence. As you close your eyes, imagine drifting through this invisible cosmos. Feel the unseen gravity guiding galaxies, the expanding space stretching endlessly around you. Know that even as a single observer on a tiny planet in a modest galaxy, you are intimately connected to these vast, invisible forces. The universe is larger, stranger, and more beautiful than anything we can fully grasp, and yet, through science, observation, and wonder, we touch its edges and feel its rhythm within us. The expanding universe, to understand the universe, we must first understand its motion. From the smallest particle to the largest supercluster, the cosmos is not static. It is expanding, stretching, evolving, a dynamic system in constant transformation. The story begins with the Big Bang. Approximately 13.8 billion years ago, the universe emerged from an incomprehensibly hot, dense state. In an instant, space itself began to expand, carrying energy, matter, and the seeds of galaxies along with it. This event was not an explosion in space, it was an expansion of space itself. Every point in the universe moved away from every other point, setting the stage for everything we see today. Very shortly after the Big Bang, the universe underwent cosmic inflation. During this brief but extraordinary phase, space expanded exponentially, faster than the speed of light. Tiny quantum fluctuations during this period were stretched across vast distances, creating the initial irregularities that would later form galaxies, clusters, and the cosmic web. Inflation laid the groundwork for the grand structure of the universe, imprinting patterns that would echo for billions of years. As the universe cooled, matter began to coalesce. Hydrogen and helium formed, clouds condensed, stars ignited, and galaxies assembled. Yet even as these structures emerged, space itself continued to expand, carrying galaxies along with it. The first clues of this expansion came in the early 20th century, through careful observation of distant galaxies. Edwin Hubble, in the 1920s, made a groundbreaking discovery. By measuring the light from galaxies, he found that almost all galaxies are moving away from us. Moreover, the farther a galaxy is, the faster it recedes. This relationship, now known as Hubble's law, revealed that the universe itself is expanding. Space is stretching, and with it, the distance between galaxies grows. For decades, astronomers assumed that this expansion might be slowing down, pulled back by gravity. Yet in the late 1990s, two independent teams made a startling discovery. The expansion of the universe is not slowing, it is accelerating. Distant supernovae appeared fainter than expected, indicating they were farther away than predicted. Some mysterious, invisible force, now called dark energy, drives this acceleration, pushing galaxies apart and shaping the fate of the cosmos. The implications of an expanding, accelerating universe are profound. If space stretches infinitely, the largest structures we can observe, superclusters, filaments, cosmic walls, are not fixed in space. They drift, slowly pulled apart, their motions dictated by gravity, dark matter, and dark energy. Over billions of years, the cosmic web itself will evolve, clusters merging in some regions while others drift into vast emptiness. Expansion is the universe's heartbeat, a rhythm that stretches across unimaginable scales of time and distance. Measuring the expansion requires precision and ingenuity. Astronomers rely on standard candles, supernovae, and variable stars to gauge distances. They measure redshift, the stretching of light caused by cosmic expansion, to determine how fast galaxies recede. Combining these methods, they map the expansion history of the universe, revealing the interplay of matter, and dark energy over cosmic time. The expanding universe also provides a window into the past. When we observe a galaxy a billion light-years away, we see it as it was a billion years ago. The farther we look, the closer we come to the moment of the Big Bang itself. Every photon carries a story, every spectrum a record of cosmic history, and through these signals, we reconstruct the evolution of everything we know. Tonight, as you drift through this meditation, imagine the universe as a vast, breathing entity. Galaxies drift apart on the stretching fabric of space, clusters form and dissolve, and the cosmic web slowly flows through billions of light years. You are a quiet observer, witnessing the expansion, feeling the subtle pulse of the cosmos, attuned to the rhythm of creation and motion. The expansion of the universe is more than a physical phenomenon. It is a reminder of scale, time, and impermanence. It shows that the cosmos is not static, that everything evolves, and that we are part of a living, dynamic system. Even as galaxies drift apart and clusters slowly separate, every element within them, the atoms, the energy, the light, continues to tell the story of the universe. As you close your eyes, picture the expanding cosmos in your mind's eye. See the galaxies slowly moving outward, space stretching between them. Visualize the cosmic web, filaments extending across hundreds of millions of light years, drifting and stretching, forming a living lattice. Feel the gentle, continuous expansion, the invisible hand of dark energy, and the quiet, enduring influence of gravity. The expanding universe invites reflection and awe. It reminds us that the cosmos is immense, dynamic, and interconnected. It connects the tiniest particles to the grandest structures, the present to the earliest moments of creation, and our awareness to the eternal motion of space itself. Gravity is the quiet sculptor of the cosmos. It is invisible, intangible, yet its influence stretches across billions of light years, guiding the motions of stars, galaxies, and clusters. From the gentle pull that keeps planets orbiting stars, to the titanic forces that shape clusters and superclusters, gravity is the fundamental architect of the universe. Every star, every planet, every galaxy owes its place in the cosmos to gravity. It is the force that gathers gas and dust into stars, that holds stellar systems together, that molds galaxies into spirals, ellipses, and irregular shapes. Without gravity, matter would remain scattered, a chaotic cloud without structure. With gravity, patterns emerge, from the smallest scales of planetary systems to the vast networks of the cosmic web. Consider a galaxy like our Milky Way. Its billions of stars orbit a common center, held in place by the combined pull of all the matter within it, both visible stars and the elusive dark matter. Gravity binds the stars together, shaping the spiral arms, stabilizing the disk, and maintaining the delicate balance between centrifugal motion and inward pull. Zooming out, gravity continues to weave its invisible threads. Galaxies are not isolated. They congregate into clusters, groups of hundreds or thousands of galaxies bound together by gravity. Within clusters, galaxies interact, collide, and merge, reshaping their structures, triggering bursts of star formation, and even awakening the dormant supermassive black holes at their centers. Gravity ensures that these cosmic communities remain coherent over billions of years, orchestrating the dance of galaxies across vast distances. Clusters themselves gather into superclusters, forming nodes along the filaments of the cosmic web. Gravity pulls matter along these filaments, guiding the flow of galaxies into larger and larger structures. The web of the universe, filaments, walls, and voids, exists because gravity shapes the distribution of mass on scales far beyond our everyday experience. Even the voids between filaments are influenced by gravity. Regions with less matter are stretched as denser areas pull material toward them. Over billions of years, this subtle tug of gravity sculpts the large-scale architecture of the universe, creating vast cosmic deserts surrounded by walls and filaments rich with galaxies. Gravity's influence is both immediate and profound. It governs the formation of stars within clouds of gas, the collapse of planets from dust, the merging of galaxies, and the bending of light across space. Gravitational lensing, for example, allows us to see galaxies behind massive clusters, their light bent and magnified by the invisible mass in between. Through this effect, we can map not only visible matter, but also the dark matter that forms the scaffolding of cosmic structure. The power of gravity extends to the very expansion of the universe. While dark energy pushes space apart, gravity works to slow this expansion, pulling clusters, filaments, and galaxies together. The interplay between expansion and gravitational attraction shapes the evolution of cosmic structure, determining the size, shape, and distribution of the universe over billions of years. Tonight, as you drift through this meditation, picture gravity as the silent conductor of a cosmic orchestra. Stars revolve, galaxies spin, clusters sway, and filaments stretch, all in response to this invisible, persistent force. It is gentle in small scales, guiding planets around stars, yet immense across cosmic distances, shaping the grand architecture of the universe. Think of the cosmic web as a living system, where gravity pulls threads together, forms nodes, and sculpts the voids in between. Every star, every galaxy, every cluster is connected by gravity, participating in a grand, ongoing dance. Even you on your tiny planet feel gravity's influence. It holds you to Earth and simultaneously connects you to the cosmic ballet unfolding across billions of light years. Gravity is both subtle and vast, intimate and cosmic. It reminds us that forces we feel every day are the same forces that structure the universe. It connects the smallest and largest scales, the familiar and the unimaginable. Through gravity, the universe organizes itself, revealing patterns, structures, and the silent order behind apparent chaos. As you close your eyes, imagine floating through space, drifting among galaxies, clusters, and filaments. Feel the invisible pull of gravity, guiding stars in their orbits, shaping clusters, weaving the cosmic web. Sense the immense, persistent reach of this fundamental force, stretching across billions of light years, linking everything in an intricate cosmic dance. Gravity, the universe's architect, the silent weaver, and the unifying force, continues its work, now and for all time. In the vastness of the universe, there exists a curious contrast, the infinite and the intimate. We are beings of flesh and thought, measuring time in heartbeats, days, and years. Yet we find ourselves adrift in a cosmos measured in billions of light years, where even light, the fastest thing we know, takes eons to cross the gulf between stars. To truly grasp the scale of the universe is to step beyond human instinct. Our brains evolved to navigate the world of trees and rivers, not galaxies and superclusters. And yet, through science, we have extended our perception far beyond our senses, into realms so immense that even imagination struggles to follow. Consider the concept of a light year. It is the distance light travels in 1 year, about 9.46 trillion kilometers, a number so large that it defies intuition. If you could travel as fast as light, it would still take over 4 years to reach the nearest star, Proxima Centauri. And that's just one star in our galactic neighborhood, one among hundreds of billions in the Milky Way. Now imagine the Milky Way itself, a grand spiral of stars stretching 100,000 light-years across. A city of suns, each with its own planets, its own histories of formation and decay. If our entire solar system were the size of a coin, the Milky Way would be the size of a continent. And yet, even this great galaxy is but a single leaf in the forest of the cosmos. Beyond it lies the Andromeda Galaxy, our nearest large neighbor, 2.5 million light-years away. In about 4 billion years, our galaxies will merge, a slow, elegant dance choreographed by gravity. Together they will form a new elliptical galaxy, perhaps called Milkomeda, a symbol of unity written in the language of stars. Beyond Andromeda are countless others, galaxies spiraling, colliding, evolving. Through telescopes, we peer into deep space, and what we see is a tapestry of light woven across cosmic time. Every distant galaxy is not only far away, but also long ago. When we look into space, we look into the past billions of years back, toward the moment when the first stars ignited. It's astonishing to think that the light striking your eyes tonight may have begun its journey before the Earth even formed. You are, in a sense, bathing in the memories of the universe. The cosmic scale challenges our sense of significance. What are we compared to galaxies, superclusters, and the cosmic web? To the universe, our lives are flickers of light in a vast darkness, moments too brief to measure on a cosmic clock. And yet within those fleeting moments, consciousness arises. Awareness capable of perceiving the stars, questioning existence, and tracing the origins of space and time itself. In this way, the small becomes infinite. For consciousness, the act of knowing allows the universe to see itself. Through your eyes, the cosmos awakens to its own immensity. Through your thoughts, it reflects upon its own mystery. Let us take a moment to reflect on the scale of time. The universe is 13.8 billion years old. Human civilization, by contrast, has existed for barely 10,000 years. If the age of the universe were compressed into a single year, with the Big Bang at midnight on January 1st, humans would appear in the final second of December 31st. Everything we call history, the pyramids, the Renaissance, the modern age would flash by in an instant. And yet, that instant is filled with meaning. It contains love, curiosity, art, science, discovery, the very essence of what it means to be conscious in a vast and ancient cosmos. In cosmic terms, we are new. But in understanding the universe, we have achieved something profound. We have learned to read the light of stars, to measure distances across billions of light years, to see galaxies being born in the young universe. We have taken the immeasurable and made it measurable, the infinite and made it thinkable. Our instruments, telescopes, satellites, detectors extend our senses. They collect ancient photons, faint signals, whispers from the edge of time. And from those whispers, we reconstruct the grand story of existence. The universe is not only vast, it is interconnected. Every atom in your body, every breath you take, carries the history of stars that lived and died long before Earth existed. The iron in your blood, the calcium in your bones, the oxygen in your lungs, all were forged in the hearts of ancient stars, scattered by supernovae, gathered into new worlds and eventually into you. So when you gaze at the night sky, you are looking at your own origins. The stars are not distant strangers, they are your ancestors. Their light is the reflection of your own story written across the heavens. From this perspective, the universe does not feel so distant. It becomes something intimate, a mirror, showing us not our smallness, but our connection to everything that is. We are atoms of the cosmos, briefly arranged into awareness, reflecting on the beauty of being. Time, distance, and space may dwarf us in size, but they cannot diminish our capacity for wonder. Science gives us the tools to measure the cosmos, but awe gives us the courage to face its immensity. And perhaps that balance between knowledge and wonder is what it means to be human in a cosmic sense. So as you listen, breathe, and drift among these thoughts, imagine yourself floating in space, watching galaxies turn like silent clocks. Imagine each second of your life as a pulse of consciousness that echoes across time. And realize that your awareness here, now, is as much a part of the universe as the galaxies themselves. You are not separate from the cosmos. You are one expression of it, a way for the universe to know its own scale. A fleeting spark of perception within an infinite expanse. In the end, perhaps perspective is not about size at all. It's about connection. To see the vastness of the cosmos and still find beauty in a grain of sand, or meaning in a heartbeat, is to understand the unity of existence. The infinite and the human, bound together by the simple act of awareness. So, rest easy, traveler of thought. You are small. Yes, but within you lies the vastness of space and time. When you look to the stars, you are looking back at yourself, a reflection of the universe, aware and alive. Strange and exotic structures. The universe is filled with wonders beyond comprehension, structures so vast, so exotic, and so powerful that they challenge everything we understand about space, time, and energy. Now we venture into the deep cosmic wilderness to meet the strangest and most awe-inspiring phenomena ever discovered. From blazing quasars to devouring black holes, from the filaments that weave the cosmic web to the vast, empty voids that stretch for hundreds of millions of light years. This is the strange architecture of the cosmos. Let us begin at the centers of galaxies, where the most mysterious objects in existence reside. Black holes. Regions of space where gravity becomes absolute, where not even light can escape. They are born from the collapse of massive stars, and yet, in their larger forms, supermassive black holes, they become the beating hearts of galaxies. In the Milky Way, our own supermassive black hole is called Sagittarius A*, a gravitational giant 4 million times more massive than our Sun. And yet it sits in the center of our galaxy, invisible to the eye, surrounded by swirling stars and glowing clouds of gas. Black holes are paradoxes of existence, infinitely dense, yet infinitely small in volume. They warp space and time, curving reality into a shape where the laws of physics as we know them begin to break down. Around them, matter forms accretion disks, spiraling rings of gas heated to millions of degrees, glowing with the energy of destruction. It is in these infernos that we find one of the most powerful phenomena in the universe, quasars. Quasars are cosmic lighthouses, powered by black holes feeding on surrounding matter. As the material falls inward, it heats up and emits intense radiation, so bright that a single quasar can outshine an entire galaxy. Some are billions of light years away, and yet their light still reaches us, crossing time itself to tell the story of a young universe filled with chaotic energy. When we look at quasars, we are peering into the distant past, to an era when galaxies were still forming, when black holes were ravenous, and when the cosmos was alive with unimaginable fire. But black holes do not simply destroy, they also shape creation. Their gravity binds galaxies together, influences star formation, and drives the evolution of galactic structures. Even when they merge, two giants spiraling toward each other in a dance of death and rebirth, they send ripples through the fabric of space-time. These ripples, known as gravitational waves, are the faint echoes of cosmic cataclysms, traveling billions of light years to reach our detectors here on Earth. Every merger, every quasar flare, every gravitational wave tells us something profound about the forces sculpting the universe. But the cosmos is not only made of these violent points of energy. It is also held together by something vast, delicate, and intricate. The cosmic web. Imagine the universe as a grand tapestry of light and darkness. Galaxies and clusters connected by invisible filaments stretching across billions of light years. These filaments are composed of dark matter and gas, guiding the flow of galaxies into vast cosmic highways. They are the structural framework of the universe, the bones of creation. If you could step back and see the universe from far enough away, you would see a web-like pattern, threads of light woven through emptiness. Galaxies gather along these threads like dewdrops on a spider's web, while enormous voids stretch between them, vast and empty. The largest of these filaments span hundreds of millions of light years. Colossal structures such as the Sloan Great Wall and the Hercules, Corona Borealis Great Wall. These are among the largest known structures in the observable universe, spanning distances that defy the imagination. And yet between these threads of light lie the dark oceans of space, the cosmic voids. These are regions where galaxies are few and far between, where matter is sparse, and where silence reigns. Cosmic voids can be hundreds of millions of light years across, and yet they are not truly empty. Within them lies the faint whisper of hydrogen, the residue of creation, the quiet hum of the cosmic microwave background echoing from the birth of the universe itself. Voids are not simply the absence of galaxies. They are essential parts of cosmic balance. They expand as the universe expands, allowing the filaments and clusters to grow denser in contrast. The universe, like a vast sponge, breathes between fullness and emptiness, an endless rhythm of matter and void. As we move deeper into the cosmic web, we find that everything, black holes, quasars, clusters, and voids, is connected. Galaxies form along filaments where matter flows like rivers through the gravitational landscape. These filaments funnel gas and dust into galaxy clusters, fueling star formation and feeding the supermassive black holes at their centers. In a way, the cosmic web is not static, it's alive. It pulses and evolves, changing shape over billions of years as the universe expands. Through the eyes of our telescopes, we have traced these threads of structure, mapping the cosmic network in 3 dimensions. It is a breathtaking vision, the universe not as a random scatter of galaxies, but as an organized, interconnected system. A structure of unimaginable beauty and complexity, where energy and matter flow like blood through the veins of a living organism. In these grand scales, we see echoes of the same patterns found in nature here on Earth, fractal, self-similar designs that repeat from the microscopic to the cosmic. The branching of trees, the flow of rivers, the neural connections in your brain, all seem to mirror the vast filaments that connect galaxies. Perhaps this is the language of the universe, structure repeating itself, from the smallest scale to the largest, written in the geometry of existence. And within this vast, interconnected web, black holes and quasars act as the engines of change. They recycle matter, ignite new stars, and regulate the growth of galaxies. Even the darkness of a black hole contributes to the light of the cosmos, through the energy it releases in its violent surroundings. It is easy to think of the universe as cold and indifferent, but when we see it through this lens, it feels almost organic. Every structure, every quasar, every filament, every void plays a part in the grand design. Nothing exists in isolation. Everything is connected through the invisible fabric of gravity, energy, and time. So, as you close your eyes and listen, imagine yourself drifting through the cosmic web. You pass clusters glowing with galaxies, each one filled with billions of stars. You glide along the filaments of dark matter, following the faint shimmer of distant light. Then you drift into a vast void, a sea of darkness so complete it feels eternal. And yet within that stillness, you sense the hum of creation, the quiet breath of the cosmos itself. The universe is not a static thing. It is a living pattern always unfolding. Quasars flare, black holes merge, filaments stretch and voids expand, all in harmony with the grand rhythm of cosmic evolution. From the smallest subatomic particles to the largest cosmic walls, every part of existence dances to the same universal tune. And you, a being of thought and awareness, are part of that dance. Made from the same atoms forged in ancient stars, you are connected to quasars, black holes, and the filaments that bind the galaxies. You are the universe, looking back upon itself, a conscious fragment of the grand design. Edge of the observable universe, there is a limit to what we can see. A cosmic horizon, an invisible boundary that marks the edge of everything we can observe. Beyond it, the universe continues, stretching into realms we can never reach, where light itself has not yet had time to arrive. This is the edge of the observable universe, the farthest frontier of human perception. When we gaze into the night sky, we are not just looking into space. We are looking into time. Every point of light, every distant star, every faint galaxy is a message from the past, ancient light that has traveled across billions of years to reach our eyes. The farther we look, the older the universe appears. Until, eventually, we reach the limit, the moment when the first light began to shine. This boundary is defined not by what lies beyond space, but by the nature of light itself. Light travels at a finite speed, about 300,000 kilometers per second. And though that is unimaginably fast, the universe is unimaginably vast. Since the Big Bang, light has only had about 13.8 billion years to travel. But because the universe has been expanding all that time, the true distance to the edge of the observable universe is far greater, about 46 billion light-years in every direction. So when we speak of the observable universe, we are describing a sphere, a cosmic bubble centered around us. Not because we are special, but because we can only observe what light has had time to reach. Every observer, anywhere in the cosmos, would have their own observable sphere. From every galaxy, the view of the universe's edge is different, and yet the same. It is a humbling thought that our entire cosmic awareness is contained within a bubble of light. Everything we have ever known, ever seen, or ever measured lies within this delicate sphere of visibility. Beyond it lies the unobservable, a realm we cannot see, cannot measure, and may never know. At the farthest edge of visibility, we encounter the cosmic microwave background, the faint afterglow of the Big Bang. It is the oldest light we can detect, the whisper of creation itself. Captured by our instruments, it appears as a bath of soft radiation, uniform, yet subtly patterned. Those patterns, tiny fluctuations in temperature, are the fingerprints of the universe's earliest structure, seeds from which galaxies would later grow. Beyond that ancient glow, the universe remains hidden. There may be galaxies, stars, and even entire cosmic structures, but their light has not yet reached us. They are forever beyond our horizon, existing in a cosmic silence we can never break. This limitation is not just physical, it is fundamental. The speed of light defines the maximum rate at which information can travel. Nothing, not even thought, not even gravity, can outrun it. This means that the edge of the observable universe is also the edge of our knowledge. Beyond it lies the unknown, not because it does not exist, but because its existence cannot yet touch us. The concept of beyond challenges our sense of reality. What does it mean for something to exist if we can never see or detect it? Are there galaxies out there, vast, distant realms of stars and life, that will forever remain beyond our sight? Almost certainly. The universe does not end at the edge of what we can observe. It continues, possibly infinitely, into regions where time and space stretch beyond imagination. Astronomers suspect that the universe may be far larger, perhaps even infinite. Our observable region may be just one small patch of a much grander cosmic landscape. Some theories even suggest that our universe could be one of many, a single bubble in a vast multiverse, where other universes expand and evolve according to their own laws of physics. If that is true, then our cosmic horizon is not the edge of everything, merely the edge of our awareness. And yet, even within this limit, what we see is enough to inspire endless wonder. The observable universe contains hundreds of billions of galaxies, each with hundreds of billions of stars. Trillions of worlds, swirling in darkness, orbiting suns across unthinkable distances. And that is only the part we can see. Beyond that, perhaps an infinite ocean of stars, galaxies, and structures, forever hidden from view. Light defines our reality. It gives shape to space and meaning to distance. But light also hides things from us. Because of its finite speed, we can never see the universe as it is now. We see it as it was. Every image, every photon that reaches us carries history. We are always looking backward in time, never in the present. In a sense, the universe we see is a kind of ghost, a memory of what once was. The galaxies we observe at the edge of the observable universe no longer exist as they appear. Their light began its journey billions of years ago. By now, those galaxies have aged, moved, or perhaps even disappeared. What we see is their ancient reflection, preserved in the fabric of space-time. This cosmic delay gives rise to a profound truth. To observe the universe is to observe time itself. Every direction you look, you are peering into the deep past, from the light of nearby stars just a few years old, to the light of distant galaxies billions of years in transit. The night sky is not a snapshot, it is a living history, and beyond that history lies something we can only imagine. Perhaps there are regions of the universe so distant that light from them will never reach us, no matter how long we wait. Their space is expanding faster than light can travel, forever separating us from them. Those realms will remain eternally unseen, hidden beyond the cosmic event horizon. Yet, even in this limitation, there is beauty. For it reminds us that mystery is not absence, it is invitation. The edge of the observable universe is not a wall, but a horizon, a place where knowledge fades into wonder. It is where science meets imagination, where observation gives way to humility. As you drift through this thought, imagine yourself at the edge of everything we can see. Ahead of you stretches the faint glow of the cosmic microwave background, the afterlight of the Big Bang, rippling gently like a cosmic sea. Beyond that, darkness, a silence so deep it feels infinite. Not empty, but unknowable, a vast beyond where reality continues in ways we cannot yet conceive. The cosmos does not end there. It simply vanishes from our sight. And yet, the thought that existence extends beyond perception fills the mind with calm awe. Because it means that creation never truly ends. It just stretches endlessly outward, beyond reach, beyond measure, beyond comprehension. We are tiny observers in a limitless sea, gazing at the faint edge of what we can know. But even that small window reveals the grandeur of existence. We have seen galaxies forming, stars dying, black holes merging, light bending through space-time, all within our little sphere of awareness. And still, we have barely glimpsed a fraction of it. As you close your eyes, imagine drifting to that cosmic edge, the border between the known and the unknown. Feel the hum of light, the whisper of ancient radiation, the silence beyond. It is not frightening. It is peaceful, infinite, serene, eternal. The universe continues, and you, a part of it, float quietly within its boundless mystery. You are both observer and observed, a consciousness formed from stardust, peering back through the ages. And though your senses are limited, your imagination is not. It reaches beyond the horizon, into the unseen, where reality stretches into the infinite. The edge of the observable universe is not an ending. It is the beginning of wonder. It is the silent frontier, where knowledge fades into eternity. And the human spirit, ever curious, continues to dream. Infinite universe, theories and speculations. When we look out into the night sky, we often assume that what we see is the totality of everything that exists. The stars, the galaxies, the faint cosmic glow left over from the Big Bang. These are the boundaries of what our telescopes can detect. But what if the visible universe is just one small island in a far greater cosmic ocean? An ocean so vast, so incomprehensible, that our entire observable universe might be just a ripple upon its surface. The idea of infinity has haunted thinkers for centuries. To say something is infinite is to admit that it has no end, no edge, no boundary, no final horizon. And yet the word universe itself means everything there is. How then could there be more than everything? Modern cosmology forces us to confront this question head-on. The universe, according to our best observations, is not only vast, it's expanding. And not just expanding, but doing so at an accelerating rate. Distant galaxies are racing away from us faster and faster, carried on the tide of spacetime itself. This acceleration was discovered through the light of ancient supernovae, dying stars whose brightness tells us how far away they are. Astronomers found that these explosions were dimmer than expected, meaning the galaxies they belonged to had sped farther away than predicted. The cause? A mysterious phenomenon called dark energy, a kind of cosmic pressure pushing everything apart. Now imagine, if the expansion never stops, if new regions of space keep forming faster than light can travel, then there may exist realms of the universe we will never see. Not because they are hidden behind stars or dust, but because light from those regions will never reach us. They are forever beyond our cosmic horizon. This brings us to a breathtaking possibility. What if our universe, the one we can observe, is only a small bubble in a much greater cosmic foam? This concept is known as the multiverse hypothesis. According to some theories of cosmic inflation, our universe began as a small fluctuation in an energy field. But inflation didn't just happen here. It could have occurred in countless other regions, each giving birth to its own universe. Imagine a vast field of cosmic energy, rippling with endless quantum fluctuations. Each fluctuation, under the right conditions, inflates into its own universe, expanding, cooling, and forming stars and galaxies of its own. Some of these universes might follow the same laws of physics we do. Others could be utterly alien, with different particles, forces, or even dimensions. Perhaps in one, gravity is stronger. In another, atoms can't form at all. And in some distant, unreachable bubble, maybe life flourishes under laws we cannot even comprehend. This is the eternal inflation model, the idea that inflation never truly ends, but continues eternally in some regions, spawning an infinite patchwork of universes, each one isolated by vast stretches of expanding space-time. It's a beautiful and humbling vision, a cosmic forest where our universe is just one tree among countless others. But what about the shape and size of our own universe? Observations of the cosmic microwave background, that faint afterglow of the Big Bang, suggest our universe is remarkably flat. In cosmology, flat doesn't mean two-dimensional. It means space itself isn't curved inward like a sphere or outward like a saddle. This flatness implies something profound. The universe may extend infinitely in all directions. If true, there could be infinite galaxies, infinite stars, infinite worlds, and perhaps even infinite copies of you, existing in regions so far away that light will never bridge the gap between them. This concept, sometimes called the level I multiverse, doesn't require new physics or exotic dimensions, just the continuation of space beyond the observable horizon. It means our cosmic neighborhood could go on forever, repeating variations of the same matter and energy endlessly across infinity. But of course, infinity brings philosophical challenges. Can something truly infinite exist in reality, or is it only a mathematical idea? If the universe is infinite, then every possible arrangement of matter must occur somewhere. Every planet, every life form, every thought. Does that mean that in another part of the infinite universe, there's another Earth, another you, listening to this very same story right now? These are not easy questions to answer. They stretch our reason and challenge our sense of self. Yet they are born naturally from the equations of physics, from the strange and beautiful mathematics that describe the early moments of the cosmos. Beyond even the multiverse lies a deeper mystery. What contains all of this? Is there an even greater reality beyond spacetime itself? Some physicists propose that all universes may be part of a single, unified structure, a cosmic wave function, governed by quantum probabilities. In this view, every possible universe exists simultaneously as a potential state within the grand equation of reality. Our universe is merely one realization among infinite others, a collapsed version of the universal wave function that we happen to experience. This idea connects with the concept of quantum cosmology, where the birth of universes follows the same quantum rules as particles in a lab. In this framework, creation itself may not have a single beginning, but an eternal process of emergence, each universe blooming like a flower in the endless garden of existence. And yet, as infinite as all this may sound, our tools are finite. We are bound by light, by time, and by the limits of our instruments. We observe a small patch of the sky and infer the rest. We build equations that fit our data, then use them to imagine what lies beyond. Perhaps that's what makes the human mind so extraordinary, the ability to reach toward infinity, even while living in a finite body on a small world, orbiting a single star. So, is the universe infinite? We don't know. Maybe it is. Maybe it folds back on itself like a cosmic loop, or maybe it stretches forever into an unseen expanse. But what we do know is that every new discovery pushes that horizon a little farther away, expanding not just our universe, but our understanding of it. As you drift now, let your mind imagine that infinite expanse. Galaxies fading into darkness, new ones being born, and beyond them, countless other realities, glowing softly in the eternal night. Each one with its own stars, its own stories, and maybe its own dreamers looking back at us. In the silence between the stars, the universe whispers one truth. Infinity is not just out there. It is also within you, the infinite capacity to wonder, to imagine, and to seek meaning in the vastness of it all. The biggest thing, the universe itself. Close your eyes and imagine once again that you are drifting among the stars. The galaxies you've visited across this journey fade gently into the distance, clusters dissolving into a soft glow, filaments weaving across eternity, the cosmic web expanding into infinity. And as you drift farther, something becomes clear. Everything you've seen, every planet, every atom, every ray of light belongs to something greater, something vast beyond comprehension. Finally, we arrive at the final realization of our journey. The biggest thing in the universe is the universe itself. For over an hour, we've explored scales beyond imagination. We began with the smallest, the flicker of atoms and particles that form everything we know. We moved upward through planets, stars, galaxies, and clusters, until we stood at the edge of the observable cosmos. We have seen that even the largest known structures, cosmic filaments and superclusters stretching billions of light years, are merely parts of something larger. And now we step back farther than ever before to see it all as one grand whole, the universe, a single, boundless entity containing all of existence. But what is the universe truly? It is not just a collection of stars and galaxies. It is the sum of space and time, matter and energy, laws and possibilities. It is the arena in which everything happens, the cosmic fabric that holds reality itself. It is, in essence, everything that has ever been and ever will be. To think of the universe as a thing almost feels inadequate. It's not an object you can touch or point to. It's not contained within anything else. It is the container, the stage, the story, and the storyteller, all at once. Every galaxy, every cloud of dust, every beam of light that crosses the void, all of it is part of a single, continuous whole. From the tiniest vibration of a quantum field to the immense arcs of galactic filaments, everything is interconnected within this cosmic tapestry. The universe is not separate pieces, it's one flowing existence. Scientists once believed the universe was static, eternal, and unchanging. But in the 20th century, that view transformed. With Hubble's discovery of cosmic expansion, we learned that the universe is alive in a way, growing, evolving, and stretching out across time. Like a balloon inflating, galaxies drift farther apart, carried by the very fabric of space itself. And when we look deep into the night sky, we're not just looking across space, we're looking back in time. The light from distant galaxies began its journey billions of years ago. The farther we look, the closer we come to the beginning, to that first cosmic spark, the moment of the Big Bang when the universe itself was born. That beginning, nearly 13.8 billion years ago, wasn't an explosion in space. It was the expansion of space. Time, matter, and energy all emerged together in a single event. Every atom in your body, every element in your bones and blood was forged in that same cosmic origin. You are not separate from the universe. You are part of it. You are made of its dust, sculpted by its forces, and animated by the same laws that guide the stars. When you look up at the night sky, you are, in a very real sense, the universe observing itself. The largest structures, superclusters, filaments, and voids reveal something profound about this grand whole. They are not random. They form a pattern, a cosmic web, intricate and interconnected, as if the universe has its own architecture, its own design. If you could step outside the cosmos and look down upon it, you might see vast luminous threads stretching across the darkness, connecting islands of galaxies. These filaments resemble neural networks, the kind found in your brain. Billions of galaxies linked by invisible gravity, much like billions of neurons connected by synapses. It's as if the structure of the universe echoes the structure of the mind that contemplates it. Could it be that the universe, in its totality, is something more than just matter and energy, something aware in a way beyond our understanding? Some scientists and philosophers have wondered whether consciousness itself is a cosmic property, not confined to individual beings, but a feature of the universe as a whole. If so, then our awareness is not a small light flickering in the dark, but a reflection of the infinite awareness of the cosmos itself. Even without delving into such deep speculation, the scientific truth alone is astonishing. Every point of space, every photon, every atom, every quantum field is part of one immense continuum. There is no true boundary between you and the stars, between your breath and the interstellar clouds that formed your atoms. The carbon in your cells was once the heart of a dying star. The iron in your blood was born in a supernova. And the water that sustains your life is older than the earth itself. To realize this is to awaken a sense of belonging, not just to a planet, but to a universe. To feel that you are, quite literally, made of stardust, and that the vastness you gaze upon is, in a quiet way, your home. Now take a slow breath. Feel it move through you. Every breath you take connects you to the cosmos, to the plants that release oxygen, to the oceans that cradle life, to the stars that birth the atoms of that air. You are part of an unbroken chain stretching back to the dawn of time. When you think about the biggest thing, it's easy to imagine something out there, distant, unreachable, unimaginably large. But the truth is, the biggest thing is everything. The universe isn't just out there, it's in here, within every cell, every thought, every heartbeat. It's not something you observe, it's something you are. From particles to planets, from galaxies to the cosmic web, Every scale of existence converges into one. The universe, complete, connected, and alive with possibility. It is the ultimate, largest thing, not only because it contains all that exists, but because it is all that exists. As you drift into the gentle hum of the cosmos, remember, you are part of that immensity. The same forces that sculpt galaxies shape you. The same light that travels across billions of years once shone in the atoms that form your body. And when you wonder about the universe, it is the universe wondering about itself. The mystery of existence remains, and perhaps it always will. But that's what makes it beautiful. Because in that mystery lies wonder. In that wonder lies curiosity. And in curiosity lies everything that makes us human. So, as this journey comes to an end, let the stars remind you. You are not small, you are infinite in your connection to all things. You are the cosmos, briefly awake, exploring its own grandeur. The biggest thing in the universe is the universe itself. And you are part of its story.